Welcome back, folks, to the last section of the planes of prototypes. Hope you had a great time with all those challenges, and weren't they a doozy? Yeah. Let's turn to our next topic. Useful properties in the object prototype. Yeah, remember all those cool object prototype properties that we saw at the beginning of this level? We're going to examine and use a few of those now. First one we're going to look at is the value of property. Let's say we had two variables, x and y. One gets assigned 4, and the other gets assigned the string 4. If we call x.valueOf, we'll get that property from the object prototype, and we get a 4 back as a result. If we call y.valueOf, we'll also get the string 4 back. Now, why are we trying to differentiate between these two pretty obvious things? We just want to make sure you know that the value in valueOf isn't looking for numbers necessarily, but instead returns whatever primitive type is associated with the object. That's going to come in handy pretty soon. Now, if we try to compare x.valueOf equal to y.valueOf, we get a true. Why is that? We need to be careful here. That's because the double equal sign tries to help us out, tries to be our friend, by using type coercion, which turns a number contained within a string into that actual number. So here, the 4 that was in a string actually got turned into the number 4. And so the double equal sign said, yes, these things are exactly the same. But we didn't want that. Sometimes you might, but not this time. So why should it matter to us that the number 4 is different from the string 4? Well, up to now, in the JavaScript road trip courses, we have always known that the two values that we'd be comparing would be exactly the same type. That was to sort of keep it simple for you to understand as we moved along. But as you grow in your skills as a JavaScript programmer, you're going to want to make sure that the types that you get, whether from files or from user entry, match what you're seeking. And so we need a different way to compare types as well as the values contained within those types. Enter the triple equals operator. The triple equals operator does not ignore the type of the value in the way that the double equals operator will ignore the type for us. So therefore we get sort of a truer interpretation of the equality here. And JavaScript experts will often prefer the triple equals operator over the double equals operator for this reason. Here you can see when we use a triple equals on x.valueOf and y.valueOf, we get a false. ValueOf can be used on all native JavaScript data types. So here, if we established a variable called a and assigned to it an array that contained 3 and then blind and then mice, and we called a.valueOf, we would just get the array back. It's almost like logging out the array. Same thing with the number object. You can see the number constructor being called on 6 over there. And if we logged out the value of b, we would just get 6 back. Now, you might look at all of these responses and think, they're just giving me what the variable contains, so why wouldn't I just use the variable? It's true, these particular responses are not very interesting. What's interesting, though, is when you redefine the value of method for a class's prototype. Let's take a look. What happens when we call valueOf on an object that we make ourselves? Here I've declared a tornado variable and I've assigned it a function expression. Guess what? Constructors can be function expressions too. I'm going to pass in a category, meaning the severity of the tornado, as well as the affected areas. That's going to be an array of cities. And then the maximum wind gusts. That's going to be how high the winds travel in this tornado. Next, I'll need an array of the affected areas. We'll call that cities. And inside that array, there will be other arrays. In those subarrays, in the first index will be the city, and in the second index will be the population of that city for use later. Now, to create a new tornado object, we'll establish a twister variable and pass in F5, very strong, the city's array, as well as 220 miles per hour winds. If we were to call valueOf on our new tornado object, twister, we would get a return of a tornado object with a list of all of its properties and their values. But look at the location property. It says array 3. That just tells me I've got an array with 3 entries in it. It doesn't even tell me that inside that array are some other arrays, so I don't even know what's going on there. In other words, the value of is trying to give me as much information as it knows about this object, but we have to be responsible for making that value of method better. How can we do that? By overriding a prototype's property. Let's check it out. So why might we override prototypal properties? Well, there are many situations, as you might expect, that require special functionality that's different from the first available property with that name inside the prototype chain. But we want to caution you to think of safety first in this case for overriding, because you want to make sure that you don't override a property, let's say in the object prototype level, that will affect all objects everywhere. Shoes, tornadoes, boxes, books. We don't want that necessarily for what we're about to do. We just want to override the value of method for tornadoes. So we're going to do that inside of the tornado prototype. Let's take a look. So therefore, to get a more informative result for the value of method on tornadoes, we just want to modify the tornado prototype. So what would be a good redefinition of the value of property for tornadoes? How about we make it the sum of all the potential people that are affected by this particular tornado? Let's try that. Now, to make sure we only do this in the tornado prototype, we're going to call tornado.prototype.valueof, which creates a new property inside the tornado prototype. Next, we'll assign a function to it, and inside that, we'll create a sum variable that starts at 0, and then we'll have a loop that loops over every array inside the cities array. Each time we get to a new cell in the array, we'll add the population of people associated with that city to our sum. And at the very end of our value of function, we will return the sum of those people. So now if we call twister.valueof, we no longer get that big long list of properties in the tornado object. Instead, we get 641,647 people, which is the sum of all the affected people inside of our affected cities. Take note that the value of is found now in the tornado prototype, and that comes before the object prototype in the prototype chain. So therefore, the value of method that's still in the object prototype never gets even looked at. What's cool about this kind of overriding is that our value will even update as the cities array is updated. Say the tornado spreads its damage to another location and we need to add a city to it. Let's try that. If we tried to push a new city into the cities array with a new population of 130,045, what happens now when we call twister.valueof? We get 771,692. Why is that? That's because since the cities array was passed in by reference, we'll always get an updated value for that sum every time value of is called. How cool. Moving right along to another useful prototype property, this one is called toString. Now, the default responses to the object's toString method are often very uninteresting, especially on the JavaScript native types, but overriding it can be cool. Let's take a look at what the toString method does. Over here, we've got our original x and y variables with the same values, and as you might expect, calling toString on x just turns the 4 into the string 4. Calling toString on y doesn't have much impact, just returns the exact same string. Looking at the array, a call to the toString on an array will just stringify and concatenate all the contents, but separating each entry by a comma without any white space. So, overriding toString on the array prototype is usually pretty desirable for whatever you're trying to do. Additionally, the toString method can come in handy on a function. If we established a new function here and assigned it to a variable double and then called double.toString, you can see that the entire function is logged out as a string, which can be very useful if you ever need to concatenate an entire function as a string into some formatted printout. Now let's go ahead and override our toString method inside of our tornado prototype. We want to do something cool with our toString method in a tornado. So let's bring back in our tornado constructor as well as our cities and our new twister object. And down here we're going to override the toString method inside the tornado prototype. You can see here that we assign it a function inside of which we'll start a list variable that is an empty string. What this is going to do is hold a list of the affected areas in the cities. Then we'll loop over all of the arrays inside the cities array. Inside of our loop, if we haven't yet reached the last city, then we just want to add the name of the city and a comma to our list. But if we did reach the very last city in our array, we want to use the Oxford comma style and have some good grammar and put "and" the last city. Notice here that the cities are contained in the 0 index of each sub-array. Once the loop closes, we'll know that our list variable is complete, meaning all of the cities have been concatenated correctly into one variable. Then we will return this rather large string here that says this tornado has been classified as an, and then we'll put the category in for this particular tornado, with wind gusts up to, and we'll put the wind gusts in for this tornado. New sentence, affected areas are, and notice now we concatenate the list variable in. That will put all of our cities in one spot. Potentially affecting a population of, and now this is cool, we actually are calling our overridden value of method on this. So we will get the population placed right there. Let's check it out. If we call twister.toString now, we get a very cool representation of all the data that's in our twister tornado object. It says, this tornado has been classified as an F5 with wind gusts up to 220 miles per hour. Affected areas are Kansas City, Topeka, Lenexa, and Olathe, potentially affecting a population of 771,692. Cool, huh? Next up, we're going to try to find an object's constructor and its prototype. And there are some inherited properties from the object prototype that will provide ways for us to locate those nearest prototype ancestors. Let's check that out. If we call twister.constructor here, we get the entire constructor function back as a result. Now, next, if we call the .prototype property of the constructor function, we will get the prototype object associated with that constructor. Pretty cool. So there we can see both the constructor function as well as the prototype object that has our overridden value of and toString methods. Something useful to remember here is that if a prototype object is defined for a class, meaning the class uses inheritance in some way, that prototype will always be a property of the class's constructor, and the constructor is just another function object with properties. Another way to access just the prototype would be twister.__proto__. Kinda weird, but it will give you back the exact prototype object used for twister. Now that you know how to access the prototype and the constructor, let's take a look at the hasOwnProperty method in the object prototype. This method will help you identify the location of properties, where they are stored. Searching the prototype chains for potential overridden properties is something we do a lot, and it becomes very easy with this function. What if we wanted to find the owner of a particular property? Well, we can build a function to do that. Let's check it out. So what if we wanted to be able to find a specific property within an object's prototype chain? We wanted to find which location held a specific property. Well, we can add that one to the object.prototype. That way, every object everywhere will be able to find any property that we want to look for. So here you can see we're doing object.prototype.findOwnerOfProperty, and then we assign it a function. The function takes in as a parameter the property name that we're looking for. The first thing we'll do is establish a variable called currentObject, which will be the object within which we're looking for the property currently. And at first we'll assign that to this, which means the calling object. We want to start at the calling object to see if the property is there. Next, we'll hook ourselves up with a while loop that will keep searching the prototype chain until we've tried to go beyond the object prototype, which has no prototype. So if we tried to access the prototype of the object prototype, we would get null, because object prototype is the highest prototype that you can go. Then we'll set up a conditional in which we check whether the current object has own property, the property name that we're looking for. And if it does, we'll return that current object. Why? Because if the current object has the property name that we're looking for, that means it is the closest object in hierarchy to the calling object, which means that's where it gets the method or the property from. Otherwise, if the currently examined object does not contain the property that we're looking for, then we need to proceed up the prototype chain to find that property. How do we do that? Well, we say that the current object should now be whatever the previously looked at object's prototype was. That helps us move up the prototype chain. Then, at the end, if the loop exits, we know we tried to get past the object prototype and hit null. What does that mean? That means we never found the property in any of the prototypes throughout the chain. So we should go ahead and let ourselves know that and say, no property found. So now if we call the find owner of property on Twister with the parameter value of, meaning we're looking for the value of property, well, Twister looks inside itself as an object and doesn't see any value of. So it goes up to the tornado prototype and there it is, the value of function. So our find owner of property method returns the entire tornado prototype to us as the location of the value of property. Now if we call our function on the goToOz property, well, we'll first check the Twister object, nothing there. And then we'll head up to the tornado prototype, nothing there either. Uh-oh. So now we'll trudge up to the object prototype, still nothing. Finally, we'll try to get past the object prototype, but that prototype is null. Womp womp. But actually that's cool because our while loop will exit and we'll get no property found. So we see that trying to find the goToOz property shows us that none actually exists for this particular tornado, which I have to say, kinda sucks. And that, ladies and gentlemen, is the end of Level 5, the Planes of Prototypes. Hope you've enjoyed it. We've got a few more challenges before the very end, so take some time with those, and we'll see you back for more JavaScript real soon. Take care. For example, I'm crashing is why I'm crashing. Crashing, man. New uppercase method. Properties. Well, I can't talk. I just can't do it. Method. What? All of that get pat. If I could talk. Don't put that in there.